Geothermal energy is heat energy generated and stored in the earth, which comes from the original formation of the planet and from the radioactive decay of materials. Binary cycle geothermal energy uses two fluids in its process. Pumps are used to draw hot water below 400 degrees Fahrenheit from a geothermal well within the earth, which heats a secondary fluid, called the heat transfer fluid. The secondary binary fluid has a much lower boiling point than water. When the hot water from the geothermal well passes through a heat exchanger, the heat transfer fluid flashes to vapor. The vapor turns a turbine which powers a generator. Binary cycle differs from other methods of geothermal production such as dry steam and flash steam systems due to the fact that the water or steam from the geothermal reservoir never comes into contact with the turbines. Good locations for geothermal energy are generally not close to cities or very populated areas. This is because geothermal energy locations require a certain type of rock to drill through, a certain depth to reach a liquid, and for the most part are near tectonic plate boundaries, specifically in high volcanic areas. Therefore, you may need to transport the power over large distances. Geothermal water can contain sulfur, salt, and other materials, so engineers decided to make the process a closed-loop system, so the water is recycled. Water is lost during the process, so sometimes plants are required to bring in outside water, ideally wastewater. Binary geothermal energy is a renewable resource due to its closed loop. Only water vapor is released into the atmosphere. In fact, geothermal power plants emit 97% less acid rain-causing sulfur compounds and about 99% less carbon dioxide than fossil fuel power plants of similar size. Also, geothermal energy production can be easily increased or decreased depending on demand, unlike other intermittent renewable resources. On the negative side, geothermal drilling can cause earthquakes. In fact, a 3.4 magnitude earthquake in Switzerland resulted from geothermal drilling in 2009. However, from an engineering perspective, keeping the size of the fracture small, controlling water flow rates and pressure will reduce the risk of earthquakes. Creating geothermal plants increases the number of jobs. For every 100 megawatts of geothermal capacity, 170 permanent manufacturing jobs are produced. A geothermal power plant can cost as low as $3,400 per kilowatt installed. It has a levelized cost of around $42, comparable to a natural gas power plant. One of the most active geothermal areas in the world is found along the Ring of Fire. This area encircles most of the Pacific Ocean. The western U.S. is in this ring and is the world's biggest producer of geothermal energy, coming in at a whopping 3.5 gigawatts. This is equivalent to powering 3.5 million homes. Iceland is another major player in the geothermal game. Iceland is located on a tectonic plate shift in a volcanic region. More than half of Iceland's energy is produced by geothermal. Many countries have set geothermal developmental goals to power their nation. For example, El Salvador plans for 40% of their energy to come from geothermal by 2020. Ethiopia plans to have an additional 1,000 megawatt build by the early 2020s. Many characteristics affect the amount of geothermal power a country is developing, including climate goals, size, discovered resources, amount of geothermal leases made available to developers, and the structure of a country's power market. You can see the top 5 countries with geothermal installed capacity. The future of geothermal energy will mainly be binary cycle plants. This is because the most common geothermal reservoirs close to Earth's surface have water below 300 degrees Fahrenheit, therefore relying on the binary cycle's secondary fluid. The process has environmental, societal, and economic benefits, making it a good candidate for future energy production.